Okay, so let's go ahead and start. We need to wrap up chapter 4. So this is our schedule. This is what's left, guys. When we come back from Thanksgiving, our usual 2-day review, especially with only us half meeting. But remember, this Tuesday, all are welcome, because there'll be enough who don't want to come. So anyone who wants to come on this Tuesday can come. Test on Wednesday, and then we'll review Thursday, Friday, and Monday. And then this Tuesday, there's no class, because you may have a final in a different class already. Finals start that Tuesday, and then ours is on the Wednesday. Okay, so that Tuesday, we actually don't meet, because that's when finals start. You may have some finals that Tuesday already. So we do not meet. Okay. And then notice our time, our final, we'll do it obviously next week, but it is 10:30 to 12:30. All right, so that's wrapping it up. Let's take a look at, remember Friday, I said this would be the first problem that you're gonna see. Let's see if we can evaluate this integral. You know, the directions were evaluate. This would have been the last problem. We kind of ran out of time. But really, if they show you this, it's kind of like saying, hey, I want the integral, I want the area under the curve from 0 to 5. So there really doesn't have to be much directions, but this would go with the directions that we already had, evaluate the integral. So find your notes. Let's see, can you see that? Yeah. Okay. All right, and the first thing we do is we identify the u. We also could, if we wanted to rewrite this, we could rewrite this as x plus 4 to the -1/2, and then x and dx. If that helps to look at it that way, it's kind of nice to, I think it looks like a totally different problem, and yet they say the exact same thing. Remember, square root means 1/2, and if it's on the bottom, you bring it to the top, making it negative. Okay, then we still have to identify what is the u. Any ideas what our u is? We're doing u substitution. Yeah, remember, you find that exponent. What's that other piece with it? It's that x plus 4. Okay, don't take the -1/2, but that -1/2 is the one that's saying, hey, take that quantity that's attached to that exponent. And then you actually take in the middle of an integral, or we haven't even started really, but you take the derivative. Take the derivative, we're going to write the derivative as du over dx, and that equals 1. Yeah, so we really, we could write the 1. Multiply both sides by dx. And so really we have du equals dx. Remember we said there's going to be one trick, and that's why we didn't have time to finish it on Friday. Let's also change, I think the sooner we do this, the better. Let's change this. This is an x. Let's change it to a u. Where do we go and change it to a u? Right here. So instead of 0, it is now going to be 4. 0 plus 4. And then the 5, what's the 5 going to change to? Right here is where we change it. 5, it goes in for x. 5 plus 4 takes us to 9. If you want to draw like a little line to show that we did x plus 4, and here, we did x plus 4, if that helps to remember where we did it. So here we plugged in here we plugged in the 5, and here we plugged in the 0. Okay, so where were we? Now, here's our problem. What is this going to turn into? This is going to turn into u, to the -1/2. But here's where we have our issue. What is the dx going to turn into? Yeah, it's just an even trade, and that's okay. We just need everything in terms of u. So it's going to be an even trade. The dx goes to du. But we still have this x floating around, and that's not good. That was the snafu. That's the issue that we would have had, on Friday. It would have maybe taken too long. we go right back. And usually it pops up here, right? So you may want to double check, but no, we did everything right. We took the derivative, it goes to dx. So you go back up and you use this again. So we use it to change these guys, the limits. We use it to change the dx. And now we're going to use it just for the x part. U equals x plus 4. We're going to solve that for x. If we solve that for x, what can go in place of x? U minus 4 can go in place of x. So really once you identify your u, that's how you change everything. And if it doesn't come out perfectly, then you got to go back to it again. This u is very important. So now, so we can write it again. We've changed this already. We've got u to the negative 1/2. It's times x, but what are we going to put in place of x? U minus 4. And then our du. Right? So constantly keep coming back to that whatever u equals. Now we're in good shape, but we have to, it doesn't look like we accomplished a whole lot, because take a look at this. Up here we were multiplying, but the quantity had the exponent. Now we're multiplying, but the quantity is good to go. What can we do here that we couldn't do up here? Do you see how I cannot distribute this x? I cannot do this because of the exponent. But here, I was going to draw the line, but I'm like, I don't even know if I want to do that. But here, it's okay because there is no exponent on the quantity. So take a look at that. This is not good because I'd have to perform this exponent first. But once I get rid of that exponent, now it's okay to distribute. All right, so we've got, what do we have? 4 to 9. When you multiply, what do you do with the exponents? You want to add them. So negative 1/2 plus 1 takes us to positive 1/2. And then u to the negative 1/2 times negative 4 is just negative 4, u to the negative 1/2. And now we can take the integral of each one. Add 1, divide by the new. Switch. We can add 1. Add 1, sorry. Add 1 takes us to 3/2. Divide by the new, so that would be, are we okay going right to 2/3? Dividing by 3/2 or multiplying by the reciprocal. And then here, just this, you might want to take your time anyways. 4 over 1, when we add 1, we get positive 1/2. So divide by 1/2 or multiply by 2 over 1. They don't cancel. I could put this, like if you want to see this 1/2 and this guy is the same as this guy, divide by 3/2, this is the same as multiplying by the reciprocal. This, maybe we could put an arrow, they're the same thing. Okay, and now since we changed everything to use, we're good. We're going to keep this as 4. We're going to keep that as 9 now. We've done that already. Okay, so let's just clean this up. This will stay 2/3 u to the 3/2. And then this will be minus 8 u to the 1/2. Now remember, if we don't have these, then we have to take this x plus 4 and put it back in. But since we have them, let's just leave it as u's. We've already changed everything, so we're good to go. Now you just take your time. 2/3, 9 to the 3/2, minus 8, 9 to the 1/2, and then minus, and then a bracket. We'll set it up. And then you do it all over again. 2/3, 4 to the 3/2, minus 8 times 4 to the 1/2. Okay, looks fairly messy, so use your calculator as much as you want. Remember, you can even put like parentheses here, or brackets. You do the first one with the 9, you do the second one with the 4, and then you subtract them. It looks messy, but they gave us kind of some nice numbers. Remember, what does this 2 mean? This 2 means square root. So what's the square root of 9? 3. And then 3 to the third is 27. So we've got 2 times 27 divided by 3. And then that 2 means a square root. So the square root of 9 is 3. So 8 times 3, that's not too bad. These even cancel, right? That gives us 9. So we really have 9 times 2. So that's 18 minus 24. And then same thing here, take your time. It's not as bad as it looks. That 2, or if you type it into your calculator, that's fine too. That's more than fine. Square root of 4, that 2 means square root. So the square root of 4 is 2. 2 to the third is 8. We got 2/3 times 8. There, nothing cancels. So we do have 16/3. All right, and then same thing, 1/2 means the square root. Make sure you do the square root first. So the square root of 4 is 2. So 8 times 2 takes us to -16. And then just be careful. These are still in brackets because we have to distribute that negative. I could even do this without a calculator, but otherwise 18 minus 24, and then minus 16/3, and then it actually is plus 16. Okay, you had to make, or if you want to come up with a number there first, that's fine too. Otherwise, if you're going to distribute, make sure it hits that -16. And then I got, because of that guy, it is going to stay a fraction, 14/3. All right, what does that 14/3 mean? Area under the curve from 0 to 5, even though we eventually use 4 and 9. It's the area under the curve from the area under this curve from 0 to 5. Okay. So that's what? 4 2/3. So right around 4. Okay, a little bit more than 4. What else? What else? Okay, so the trick was, or the new part was, after we took the derivative, we still had an x. So we had to go back and use u equals x plus 4 one more time. Okay. Solve it for x, and then you can plug another quantity in that has u. As long as it has u in it, it's going in. Okay, and it has to be a match. You have to put u minus 4 in for x. All right, so you can now finish that. Let's take a look. We got one more little thing to talk about. This actually comes from section 4.4. So we started 4.4 and then we went on, because I thought this would kind of be a nice one to wrap up. So this is technically part 2. But part 1 was a couple, probably 4 or 5 lessons ago. And we're doing average value of a function. Average value of a function. But value means y value. And the average y value, a y value is up and down. So the average y value is actually the average height. So we're finding the average height, the same thing as the average value of a function, because value means y value, and y value is up and down, so y value is height. Let's talk a little bit about it, and then after the problem, we'll do a picture, and I think that'll put it together even more. But the average value is just going to come from width times height. Width times height equals, that's the what's that formula? Base times height, length times width, width times height. That's the area of a rectangle. Okay, this is how we're going to find the area. So let's plug in what we know. We know that the area, and I'll show you, like I said, I'll show you in the picture how the area turns out to be a rectangle. Okay, so the area though for us, how do we find area in general? Area is a integral. Area is an integral. So this is going to be the integral from a to b on this function f of x dx. Integral goes with area. The height is what we don't know. That's what we're looking for. We'll call it average height. That we're going to solve for this. And the width is the whole thing from our start to our stop. So if I was starting at, you can just watch, if I was starting at 0 and going to 5, what would my width be? 5, right? 5 minus 0. But okay, what happens if I was starting at 2 and going to 10? What would my width be? 8, right? Or b minus a. So my width is b minus a, my start versus my stop. All right, and then because we want to get this by itself, we want a formula for average height. We're going to divide both by b minus a. And so our formula is, ignore this guy. All right, so here's our formula. Average height is equal to, and instead of writing it like this, which you totally can, but I think so this does not get mixed up with the integral. We write 1 over b minus a and then times the integral. You see how dividing, same thing as sliding it over, making it multiplication. F of x. Or you could think of it like this. Instead of dividing, you could put this over 1, and then instead of dividing, multiply by the reciprocal. Or because it's in the denominator, you just slide it off to the side. All right, so here's our little formula for average height. All right, so let's try them. Oh, let's see. Did this. Did that. Right, area by the width. Okay. So find the average. They said value. So find, I like to call it the height, but find the average value. But don't forget that is the same as the y value, which is also the same thing as height. Okay. Find the average value of the function. Sneak it on here. Okay, so the directions say find the average value of the function. Well, we know that value is talking about y value, and y value is also talking about height. Okay, then I have to give you a function. Let's do f of x equals 1 plus x squared, and then on the interval -1 to 2. Okay, so, and this is how the book writes it. I kind of like it. We're going to do f of the average. That's kind of like saying the y value average, the height average. And we're going to use a formula 1 over b minus a, the integral from a to b, f of x dx. Because remember, this is the area and this is the width. And when we multiply, well, technically when we divide those, right? But we change this, instead of division, we change it to multiplication. That gives us the height. All right, so let's find it. What is 1 over, what is this going to be? just take your time. It's going to be 2 minus, and then a just happens to be -1. So this is my start, that's my stop. And then we're going from -1 to 2, and it's on 1 plus x squared dx. All right, so this is going to actually, because those two negatives, that gives us 1/3. Here we actually have to then just take your time. We have to actually take the integral here, right? So we want to do add 1, divide by the new. So 1 goes to, we haven't done this. 1 goes to x, and then that goes, x squared goes to add 1, so 3, and then divide by the new, so 1/3. And then we're going from -1 to 2. Okay, so we've got, it's up to you how, if you wanna just pull this 1/3 off and kind of hang on to it, let's like this, you can, and we can just plug in the 2 plus 1/3, 2 cubed, and then minus, and then we plug in a -1. And then we just work it out, and then we're going to take it times the 1/3. So this gives us what? This is what? 2 plus, this would be 8/3. And then this is -1. And this would be -1/3, because the negative cubed would still stay negative. We could distribute. So we've got 2 plus 8/3 plus 1, and then plus 1/3. So that takes us to what? This actually gives us, and you could use a calculator if you want, this gives us what, 3, 4, 5, 6? Now don't forget, that's the only thing, don't forget 6, but I still have to take it times my 1/3. So it is 2. Now, what is the 2? 2 is our answer, but what does that 2 mean? That's not the area under the curve. That is the average height, okay? Let's just do a quick picture. We've got time. So, did I go too quick? Well, okay. Just holler if you need it back. All right, so let me graph. What was our graph? X squared plus 1. Okay, so that means it moves up 1, and we're going from -1, from -1, I think -1 is like, -1 would be there, and then 2 is all the way at 5. So this is, so instead of finding, okay, so this is, if we make this 2, are we okay with that? Instead of finding the area, we're talking about the same, we're talking about this same area. That's the area that we're talking about. But we want to know the average height. The average height was 2. So if I take a look at this rectangle from -1 to 2, and then actually a height of 2, I think that lands right there. What do we know about the purple? How does that turn out? Is that hard to see here? Not too bad. The purple area and the red area, they are equal. The purple area and the red rectangle is equal. Because we took, remember, we took the purple area. I should have done that in purple. Remember, we took the purple area and we actually divided it by our width. That was our B minus A. And that's going to give us this average height of 2. So basically, when we do that little formula, we're taking the area and we're putting it into a rectangle. We want to see that average height. What would that height be if it formed, that same area formed a rectangle with the same endpoints? So that's a height of 2. That's what we're finding. We're finding the height of that rectangle. Red area and purple area are the same. All right, should we try another one? Let's do, I got 2 more. Okay, and then we got one other thing we want to look at. So f of x is equal to the 4th root of x, and we're going from 1 to 16. We want to find that average height. So we want the average height. If we took the area from 1 to 16, what would it look like, or what would the shape of the rectangle look like? We actually know it's already from 1 to 16, so all we need then is the height of that rectangle. That's considered the average value of the function, average height. All right, so we want 1 over b minus a integral from a to b of f of x. All right, so just take your time, because there's definitely a lot of fractions involved here. So it is going to be 16 minus 1. And then we got the integral from 1 to 16 of we could write this as the 4th root of x. What's the first thing, though, we're going to want to do with that? Instead of writing it as x, the 4th root of x, we want to write it as x to the 1/4. Yeah, but it might be good to see that where it's coming from. But yeah, the first thing, we have to do it anyways, because this way we'll change this to 1/15. And then this, we can change x to the 1/4. Okay, so now we can take the integral. It's not that big. So we can add 1, which takes us to 5/4. And we still have this 1/15. Divide by 5/4 or multiply by 4/5. So unfortunately, those 5s don't cancel. That would have been nice. But. All right, so what does that give us? 4 over 75, x to the 5/4, and we're going from 1 to 16. So we have already taken into consideration that 1/15, so we're good. Okay, so it's 4 over 75, 16 to the 5/4 minus 4 over 75, make sure I do a bracket, 1 to the 5/4. And then again, as much as your calculator, you know, however you feel comfortable getting this. 4th root, that 4 means a 4th root of 16. Does anyone know that? 4th root of 16 is 2. Yep, good, very good. 2, and then 2 to the 5th is 32. Otherwise, if you just type it into your calculator, that's okay. Good. So that gives us what, 128 over 75, right? And then 1 to the 5/4, that's still going to be 1. So that's at least nice. So this then is just 4 over 75. And then just make sure that you subtract. That's not bad. So what do we get? 124 over 75. And I don't think that reduces. What is that answer, though? That is the height of that rectangle. That's the height of the, or the function average. We call it the function average. All right, let's do one. We got to do one of trig, right? Who wants to do trig? Kind of messy. All right, let's take a look. All right, so our function is, we'll keep it basic for trig. We're going to do sine of x, and then we're going from pi over 2 to pi. Same direction, we want that average, the average of the function or the average height. So formula 1 over b minus a times from the integral f of x dx. This is our area. Technically, this is divided by the width. That gives us the height. All right, so this looks a little crazy. This is pi minus pi over 2. But that's the same as 1 pi minus 1/2 pi. Well, it's not too bad. You just subtract the numbers. 1 minus 1/2 gives you 1/2. So it's 1 over, and then it would be 1/2 pi. Which, and it depends how much you want to think of this. So pi minus pi over 2, you just do the numbers. 1 minus 1/2, and the pi just tags along. We'll take this back to writing this as pi over 2. And then instead of dividing, we're going to multiply by the reciprocal. So this actually turns into 2 divided by pi. So that was just a little bit of work. We haven't even got to the integral. Look out. All right. Does that make sense though? Watch you just do the coefficients. Think of pi as like a variable. You just do the coefficients. All right. So the integral from pi over 2 to pi, and we're doing it on sine of x dx. Okay, so the integral of sine, derivative of sine is cosine. Derivative of cosine is negative sine. Can we even see that? Derivative of sine is cosine, derivative of cosine is negative sine. So the derivative of negative cosine is sine. Okay. So remember, you might have to write those down, just write them down once at the beginning of the test. That way, when we can look, sine, what is the integral of sine? The negative cosine. So the integral is negative cosine, and then we're going from pi over 2 to pi. All right, so we plug in pi, so negative cosine of pi, and then just be careful, minus, and then negative cosine of pi over 2. These brackets are just because when we're done, we still have to take into consideration 2 divided by 5. Okay, so where is this guy? Let's do it actually right here. Pi is here. It's -1, 0. Cosine is the x value. So the x value is -1, and then we have that extra negative there. So okay, so we've got this 2 pi floating out here. We've got this negative, and then cosine of pi is -1. And we got this minus. This minus is this guy. All right, what's cosine of pi over 2? Pi over 2 is up here. 0, 1. So cosine is x, and x is 0. So that at least turns out, that looks kind of messy. This is a minus. Technically, it's negative, but then that whole thing is 0. Okay, so we don't even worry about this, though we could change these both to plus if we wanted to. These definitely, let's change to plus. So it's 2 divided by pi, and then all of this turns out to be 1, right? This is 1 plus 0, 2 over pi. And what's that guy? That guy is the average, we call it the average value of the function, which really correlates to that average height. This is like if we divide 2 divided by like 3.14, we get something like 0.6366. So if we wanted to do a picture, here's pi over 2 and here's pi. So from pi over 2 to pi, my function goes up. So this, the sine wave goes like this, right there. It has, there's more to it. It actually curves like this. Do we remember the sine wave? Comes up, comes down, comes up. Can we see any of this? Okay. So I'm going from here to here. Okay. So this area, now what is the average height? And this, does anyone know where this is? Does anyone know where that is? The height of sine is, anyone want to guess? Nope. How high does sine go? Well, look, my y values, this is the highest. My y value is 1. So this is 1 up here. Your sine goes between 1 and -1. Okay? And so our red rectangle has a height then of 2 divided by pi, which is like 0.6. So my rectangle, and remember I'm going from pi over 2 to pi still. So like pi, so maybe a little bit like this. So what do we know about that blue area and that red area? Those are the same. And this red has a height of, we know its width. Its height is 2 over. All right, so we're taking this area and we're trying to form it in a perfect rectangle. And this then, that's the average height, but that we also consider that 2 divided by pi the average value of the function. All right. Good. Okay, so you got those. Let's take a look at, and if you don't have it, that's okay. I told you a long time ago, I wanted to show you this. See if you can find the worksheet 4.1 part 2. If not, I think you'll be able to watch it and you'll be okay. Remember, it all started out by finding, it might be nice to kind of tie it all back in, area of these rectangles under the curve. And this chart is actually kind of nice because they did it for, they had a computer, the book talks about 10 rectangles, remember, from the left endpoint and the right endpoint. And then 20 rectangles from the left and from the right. Okay, 30 rectangles. And we said 1,000 rectangles, which they had it do it computer-wise, but do we see how we're getting closer and closer? These numbers should start getting closer and closer to each other, because the more rectangles you have, the more accurate. Remember, these numbers are all approximating the exact same area, the area under this curve from 0 to 1. Okay? But the more rectangles you have, the accurate. So all these numbers are approximating the same area, but the goal is the more rectangles you get, the closer you are to the actual number. But now we actually know, let's find this. So at 1,000 rectangles, we have 0.3328335 or 0.3338335, okay? So let's actually find the exact area. The equation was x squared, and it was going from 0 to 1. And if you want to watch, that's okay. So what is that? That's the integral from 0 to 1 of x squared dx. Taking those rectangles, doing infinite amount of rectangles, not just 1,000, not just 2,000. Now we know we're going to add 1, divide by the new. So that gives us x to the third, and then divided by 3. You could write or 1/3, either way. And we're going from 0 to 1. We plug in a 1, we get 1/3, 1 to the 1/3, 1 to the third, minus 1/3, 0 to the third. And so what is the exact area under that curve? Well, this whole thing drops out. 1 to the third is 1 times 1/3, 1/3, which is what? 0.3 repeating. So how close was our little chart? 0.3 repeating. I mean, it took a while to get there for this problem. I mean, at 1,000 rectangles, it was only accurate to about a couple decimal places. But can you see now how these numbers are approaching 0.3 repeating if we kept doing more and more rectangles? All right. All right, let's take a look at, flip, if you have this, flip this over. It says the speedometer readings for a car at 5-second intervals are given in the following table. This is velocity. What happens if we take the integral of velocity? If we take the integral of velocity, we get distance. Because when we took the derivative of distance, we got velocity. So if we take the integral of velocity, we actually come up with distance. And so here, we don't have an equation, which is actually kind of nice. We don't have an equation. Here's my rectangle. My rectangle is here. What's the width of my rectangle? I'm going in 5-second intervals. So the width of this rectangle is 5. The height of the rectangle, well, it's either, the height is the y value. Y value is height. And so I just need to know, do I want to do the left side or the right side? So estimate the distance traveled just by taking a stopwatch. We don't have an equation. This is kind of cool stuff. So we're just going to do it with rectangles. So my width is 5, beginning time intervals. So 5 times 25. Plus, here's my rectangle. My width is 5. My height is beginning intervals. So my height, remember, y value and height go together. So this is my y value, 31. 5 and 35. Did I already draw this one? This one here is going to be 5 and 43. This one here is 5 and 47. And my last one is 5 and 46. Or remember, you could actually just, and you can multiply them out, or you could factor out the 5 and just do 25 plus 31 plus 35 plus 43 plus 47 plus 46. Okay. How come I don't use 41? Because that is a end value, right? That's an end value. So I do my beginnings, so I only do the 46. And that gives me, if I do it this way, I get 5 times 227, which gives me 1,135. Even though it's kind of weird, even though it's an area under the curve, when we go to when we take the integral of velocity, we actually find the distance. And so it is in feet. All right, how about this next one? So using end time periods. So we know our interval is 5. We could even do the 5. And then our end, what's the first number that we're going to use? Our end y value is, what did you say? Yeah, 31. Yeah, so now we're doing this rectangle, but we're using this side. So now it's going to be 31. this rectangle, but now we're going to use 35, 43, 47, 46, and then this time we will use the 41 because now we're using the end. But remember, when we had an equation, we had to take this number and plug it in and find y. It's kind of nice in this situation, we have y. We don't have to take 5 and plug it in. We don't even have the equation to plug it into, but we already have the y value. And so this is our, so this one turns out to be 243, 1,215 feet. Now, these two numbers are representing the same thing, right? Because we're only doing rectangles, they're only approximations, all right? So if you wanted then to kind of like average those two together, you could do something like that. These two represent the same thing. It's just taking which side are we going to do it at. If we wanted it more accurate, if we thought this was too far apart, we'd have to go back and redo our times and maybe make these smaller. So that maybe every 2 seconds instead of every 5 seconds. All right, how about this one? Suppose a volcano is erupting and readings, the rate of solid material spewed into the atmosphere is given in the table. Time is measured in seconds. Units, metric tons is, I don't know, tonas? I don't know. I'll have to look up how to pronounce that. But it's metric tons per second. Give upper and lower estimates for the total quantity of erupted material after 12 seconds. So we've got this volcano. We want to know how much material has come up. Okay, so they take the times and then they take these metric tons. Now, I don't know how they would determine, maybe they could take a picture of it and the size of it, they could determine how much it weighed. I don't know, but okay, so how would we do an estimate? Let's just do one. Let's just do lower estimate. Lower estimate. My first rectangle is here. What's the width? The width is 2. And what's the height if I'm using lower? Remember, this is just an estimate. So the lower would be the y value on the left, which is 2. Next rectangle, width of 2, height of 10. Okay, do we get the idea? Width of 2, height of 24. Width of 2, height of 36. We'll stop there. And then width of 2, where was I? Width of, so I did this width of 36, right? So now this one is width of 46, and then last one width of 54. This is my last rectangle. How come I don't use 60? Because we are doing left endpoints. And that's it. That'll be my estimate. I got 460 metric tons. So those are kind of cool because it's kind of, if we're doing like the integral, but we're just using the values, we're just doing approximations because we're doing it with rectangles. All right, so you can now do, I know we went a little long, but no class tomorrow, so you can now go back to 4.1 and try these 2 word problems. Maybe I'll make them extra credit. I'll make them extra credit. I'll make these extra credit. So I'll go back and change these to extra credit, but you can now do those. You can now finish 4.5, that very first problem we did, and then we've got 4.4. Okay. I think if you total all of them up, there's 6 problems, including these that I'll make extra credit. And you still got tomorrow, but no class tomorrow. Okay. should I write down, I know we're running out of time. Should I write down what the homework is? So if you're good, you're good. If the other thing is, does anyone want the review worksheet that we're going to be working on Monday? Or you want to just pick it up on Monday? Let me say this. I will put it on eLearn. So if you want the review worksheet and you don't have it, but you want to start it over break, then just pick it up and just do it on eLearn. Say that again.
Does Sendry want like a certain way to put in the problem?
No, all the answers though on the homework are fractions, but on tonight's. It should be 3 fractions. Yeah.
So you're saying that the average height or the average value of a function is equivalent to area? No,
not the average. The average height only tells you where was that rectangle? So
it just always looks like it's so perfect, just chop it off.
Yeah, and that's perfect, and that's what we want. But we wanted to find this average height. How tall should this rectangle be so that the 2 areas are the same?
Oh, okay.
How tall do we want the rectangle so that the 2 areas do match?
Okay, all right. I see. I didn't know we were doing so where they did match.
Yes.
I thought we were just like, what is the average height of all the points then? And it's like, oh, it's 2. Oh, it's just convenient. It's the same. But I was like, huh, why do we do the other way when we just find the average value then? But I assume that it's not.
Are you sure? Does that make sense?
I mean, it does make sense, but then again, I can make myself think any of this makes sense. I don't know why.